Next up, we have a syslog over IPv6. Again, you're seeing a theme here. Nothing has changed in the configuration process from IPv4 to IPv6 in Air OS 8.0 and later. Again, we have our management, and then we have our IPv4 address. Again, we have IPv6 address, IPv4 address, and then our syslog server, which resides completely in IPv6. Now, really, all we need to do is point this to this, and we win. We're done, right? So what we need to do here, you can see the syslog server IP address is 10.10.10.10. This is IPv4 or IPv6. The syslog server itself is where we actually list this. That's where we're actually listing out the syslog server itself. Next, we set the level that we're going to record at, our syslog facility, local users that only allowed there. Message log, so errors, console level, disabled, file info, trace info. So we're deciding what level we're sending up to the syslog server in IPv6. Remember, this is under management, logs, and config. So let's go ahead out into our environment. We're using a different tab again, management, logs, and then config. Once we're here, you can see IPv4 or IPv6 address. We can see the syslog server. We can see the number of errors critical. Where do we want to be? Do we want to be at the debug level, or do we only want emergencies logged to the syslog? You as an administrator are going to have to make that decision based on the size of your syslog and how often you want it to rotate. Remember, the lower it is on the scale, the more syslog messages are going to be generated. The more often, depending on the size of your syslog server, the more often those logs are going to rotate, the less you'll be able to see further in the past. It limits your time scope, right? So we also have our syslog facility. What are we using it for? Kernel, FTP daemons, authorization. What are we looking at our syslog facility? Buffer log level, again, the same thing. Message log configuration, we're defining what we're looking for. File info and trace info. So very, very easy syslog configuration. Those of you who have worked with it in the past, it's not super difficult. And remember, the process is the same for IPv4 and IPv6 in your environment. Okay, next on our list is the Snmp trap receiver for IPv6. When we talk about Air OS 8.0, we do have Snmp MIBs, so Snmp MIBs being sent directly to IPv6 addresses. Okay, that's what we have happening. We're not doing any type of translation. It's being sent directly to that IPv6 address. Again, this is the very same environment we saw in many of our other configs for IPv6. We have our management, we have our IPv4 or IPv6 router, and then we have our trap receiver, okay, the SNMP server, as many of you call it. We have our community name, whether it is private, public, or whatever we have listed. We have our IPv4 or IPv6 address. You can see that matches up with what? It matches up with the service for our SNMP trap, okay? Then we're going to enable, that's the status, we're going to enable, and then we're going to enable or disable IPsec if we want a privacy or encryption to take place for these SNMP traps. Now, if you're running prime infrastructure, PI 2.2 or later, you can actually set up IPv6 SNMP traps for prime infrastructure if you're doing that. So you need 2.2 or plus for those SNMP traps for prime infrastructure. Okay, SNMP traps, I forgot the traps part. So again, this is a very simple configuration. We go to management and trap receivers. It's very simple to set up. Let's do it in this environment. We have plenty of time here. There's no run on time. So we're here at management. I'm going to click on SNMP. And then what am I looking for? Trap receivers, okay? Once I have the trap receiver, I can then point that to where? Well, the community name. Where is the community name for this? And then my actual service. I'm pointing to the SNMP server where I'm going to actually deliver this information. Really cool feature. Everybody likes Snmp. Really allows us a lot of information in our environment. Now, in our environments, we now have the ability to support ping version 6. Like I said, in Air OS 8.0, they added all the bells and whistles. And this isn't really a difficult thing here. We can do this through the CLI, or we can do this through the actual GUI interface. So how do we do this in the GUI interface? Well, there's a little ping command right here. Let's focus on the CLI because I'll jump into the GUI after this. The CLI itself is not any different from any switch or router you've ever configured in the past. If you've never done any of that in your life, I expect you to go out and do that now. Very simple process. The command is ping. That's the command. And then you put in the address you're trying to reach, not your address, the address you're trying to reach. This is a very important troubleshooting tool. All network administrators know this already. If you don't, if you're a network administrator who doesn't use this, and you would be the exception, not the rule. Let me explain what this does. In the OSI 7-layer model, what we do with ping is we cut the model in half, right? We have 7 layers of the OSI model, right? Goodness. 6, 5, 4, 3, 2, 1. Okay. What we do with ping is we cut this model right here, and we're testing the stack down. Ping actually tests layer 3 connectivity at this layer. So when I ping this address, I'm testing to see if connectivity is working from layer 3 down. If I have connectivity from layer 3 down, in the most cases, I can move on to other troubleshooting tips. I can move on to other troubleshooting areas. Those of you who work in the real world or have worked with routers and switches use this all the time. It's not really a big deal to discuss this, but I just wanted to get that off my chest. Really great troubleshooting tool. Cuts the OSI troubleshooting methodology in half. So you basically figured out which side your problem really exists. Okay, so I promised I would show you the ping within GUI, so let's go do that now. You can see it. It's right up here in the upper right-hand side. It says ping. We click on ping, and it just says enter the IPv4 or IPv6 address to ping. Just to break with our IPv6 discussion, I know you guys are probably getting sick of it, I'm going to put in an IPv4 address, just for giggles. Don't get mad. I could put in an IPv6 address in there. Reply received, so send count, receive count, so I could see that I'm doing great here. Nothing, no major problems at all. The ping was, the ping was successful, so we're fine there. And just as easily, I could have put in an IPv6 address there. I don't want you to think just because I used IPv4 that that's not acceptable. IPv4 and IPv6, both acceptable in the GUI ping command. All right, so some additional features that are supported really quickly are CDP, Cisco Discovery Protocol version 6. So using complete link local addressing to exchange those information packets. Data DTLS is also supported with IPv6, and web authorization for pure IPv6 clients. So if you're going to an IPv6 address, you can be authorized in this environment. So lots of additional supports and services added to our IPv6 support in 8.0. So remember, Air OS 8.0 and above, almost complete full IPv6 implementation. There was the virtual address and a couple other virtual addresses that were in IPv4, but even in the back end, those were traded into IPv6 addresses for us. So really good breakdown of what's supported for IPv6 in Air OS 8.0 and above.